Good evening, everyone. Welcome to the 128th video on misconceptions in physics. Okay, so my name is Ratankar Rao. I teach physics in an international school in Bangalore, and my hobby is to do videos in physics. And I love to solve more number of problems. If you ask me, can I solve JE Advanced? To some extent, I can do it. Okay, but I love to solve problems, and I also love to look at why students make mistakes while solving their problems. Everyone is not fascinated about problem solving. Some of them are, some of them think, okay, I can just mug up by heart and write it. Okay, but the original reason here as why, even though you learn so much amount of formulas, concepts, derivations, everything, but still when it comes to a numerical, you make a mistake. So what could be the reason? So I just ponder into it and I have come across a set of problems which looks, okay, which has one concept but two different situations or context. And as a result of it, I observe that most of them do make a mistake in such problems. So I have just taken about all those problems and put it over here. So these are the problems I have given to my students so far in my complete teaching arena, that is for the past 2 decades. And I have observed these problems similarly in every batch, children make a mistake. And then I look into it as why does it happen? And the result is 127 videos are gone and there's a 128th video. Okay, without wasting much of my time, if you want to see all the videos, you can subscribe to my channel and scroll across in my video list. You'll be able to see that. Or if you want to see chapter wise, what you can do is you can go to my website. My website is here. So which is ratankar.com. You can go to it and then you will be able to access all my videos. There's a second way. And then if you still have some problems and you think, okay, you're not able to solve it. No, I'm sorry. If you are able to solve it, but you're not getting a correct answer, and something goes in your mind saying that why shouldn't I attempt by this method? Okay, then do write back to me because that would be more fascinating, more interesting. And the set of problems that you see here are all very similar to it. The students say that, sir, when I can do this problem in this manner, okay, why are you insisting me that this is the right answer? Why can't I go by the old method? Or they will also ask, in fact, they don't ask, I ask the question, where can you apply this method? Okay, that's the way of my teaching. Okay, so every video will have 3 parts. The first part tells you about the problem. The second part tells you the student response. And then I'll also tell you that the concept was correct, but he did not apply it in the right context and where he can apply. That's the second part. And the third part, the correct solution. Okay, enjoy the trip. Now let us start with the problems. So we are currently working on logical reasoning problems towards it. Today's video is 128th video and 7 such problems are already been done. Now my focus is only on mechanics. We are not crossed beyond mechanics. The target is something like around 365 problems for 1 year. Let us see, I think 128 problems have already been done for the past 3 months. Let me see how much I will be able to contribute to this. Okay, now, so let us read the problem. 2 children are sitting on a moving train. One child places, okay, let me draw a moving train. I'm not drawing a full moving train. I'm drawing a platform. And this is the platform. These are the wheels. And the train is moving in the forward direction. Okay. And then one child places a ball on the floor. You put a ball on the floor. And the other child places a bag on the floor. Okay, why should you put a bag on the floor? God only knows. Okay. When the train comes to a halt, okay, train abruptly comes to a halt, the ball rolls forward. Okay, the ball only moves forward. Why does the ball only roll forward? The reason is because simple. अरे यार इसका mass थोड़ा ज़्यादा है. Maybe this mass is more higher as compared to this mass. And maybe there's a lot of friction here. As a result of it only, ball will have lesser friction. This has more friction. You can answer that also. And maybe if you ask you can also say maybe the surface area here is much lesser, only 0.1 point of contact. Okay, and here the surface is much larger. Okay, so you can give so many examples over here. You can suggest it. In fact, this was one of the questions being asked. Okay, I'm just giving you the answers. This question is not here. So this kind of questions can also come. Okay, and now, so what is the question? The actual question here is when the train comes to solve, the ball rolls forward. The ball rolls forward. Use Newton's law to explain the phenomena. Okay, now the student had answered, most of my students had answered this as the moving train produces a force on the ball. Okay, as the train moves, it produces a force on the ball. Okay, and then when the train stops, the reaction force is opposite to the train's motion. When the train stops, there's an action and a reaction, both are equal and opposite. So this, he says, this is my action. Okay, when this is stopping, then this starts moving. Okay, I'll write like this. Maybe then you can get it. Train stops, ball moves. Right? You can say this is action, this is reaction. And then they also think that when train moves, ball stops. That's what has been observed. See, what happens is sometimes we lose our intuition of understanding physics behind a given phenomena, and we just think, okay, whatever we observe is the right physics, and that's where things go wrong. Okay, so this is a big misconception because I'm not able to explain why you call this action. Now, what is action actually? Action is nothing but the force acting on an object. That is called as an action. Okay, reaction is that, okay, when the object is being given by the force, when the object is given a force, the object responds back to it and say, hey, I'm not going to take up this force. I'm going to respond back to you. I'm going to react to it. Right? That's your reaction. So therefore, now here, there's no action here. When I say the moving train, there's a train moving. Did I explain the train is accelerating? No. In the problem, I have not said it's accelerating, nor have I given anything with velocity. So it says when the train comes to a halt, the ball rolls forward. Now let us understand that nothing as such has been given. So therefore, this is a misconception. Okay. This kind of reasoning is not correct. Many of them had written like this. 80% of the students had written something like this. So I took up this problem as an interesting one. There's not much of calculation, only reasoning is there. Okay, now, actually speaking, you should not use your Newton's law of motion 3. You shouldn't use your third law of motion. You shouldn't use this one here. But what you should do is use it. You should use NLM 1. NLM stands for Newton's law of motion. Okay. What is this? What do you mean by Newton's law of motion? Was this law of motion is also called as inertia. Inertia. What is inertia? Inertia is nothing but laziness. Laziness. What is laziness? People laugh at me saying, what is laziness here? How can an object which is lifeless object can have laziness? Okay. Every object in this universe has this tendency to either stay at rest or to move in uniform motion if it is continuous to move. Okay. Why? If you want to change the state of rest or of uniform motion, you need to apply a force. An object is at rest. For example, I am sitting before you, I am explaining something. If someone wants to move me, then what you do is, I should apply a force and I should go backward like this, right? I should go backward like this. And if I want to come, then I should come pull forward like this, right? I'm holding my table here, I'm pulling myself over here. So therefore, there's a force required for an object to change its state. The state was at rest. This is your Newton's first law. Okay, now coming back to this. Now, Newton's first law is very much used. Now, initially, train was moving, okay, no force was acting on the ball. Okay, ball was also stationary. Now, train suddenly came to a halt. When train suddenly came to a halt, then the train's inertia was disturbed. The train's inertia was disturbed. Agreed, right? Train's inertia was disturbed. Every object in this universe is lazy enough, right? But this ball's inertia, so what happened over here? So this ball's inertia was also disturbed. So initially, okay, before, when the moment I applied a brake here, this inertia was disturbed. But did I apply a brake to the ball? I did not apply a brake. So as a result of it, the ball now continues to move with an uniform speed. Okay, but after some time, the ball's velocity will now reduce. Why should it reduce? Because as the ball moves, there's a friction on the floor over here. This friction will say, hey, I'm not going to let you go forward. I'm going to stop you. So this pulls the ball backwards. In other words, there's a reaction force, there's a frictional force acting in the opposite direction. As the ball starts moving and stops after a while over here. Right? So thus, the law of inertia should be used. So what should be the answer here? The answer here should be the ball moves forward because the inertia of rest is being disturbed. Okay, and as a result of this, the ball moves forward. Why does it get disturbed? Because the train stops abruptly, and as a result of it, the ball is still in the same state. It thinks, okay, I am still going in the same velocity. But suddenly when you apply a brake, the ball doesn't understand that because you are not applying a brake on the ball. Now let us say, for example, the ball is being glued to the surface. Ball is being glued to the surface. Or maybe you put a cage over here, you put nail over here, you nail it over here and say, hey, the ball cannot move. What will happen? Or maybe you put your leg on top of it. And then as the train is moving, you apply the brake. You are not lifting your head and leg. And as a result of it, the ball does not move. Right? So which means what? So you are now somehow restricting the ball's motion. But when the ball is free, it is free to move, right? So that is what is happening. And thus, the right answer comes from Newton's first law of motion, which tells you that the inertia of motion is being disturbed over here. And as a result of it, the ball continues to move. I hope you have understood this. Hey, where is it? Just a minute. Okay. I hope you have understood this video clearly. And if you have any more doubts, you can always write back to me. I'll be happy to help you out. Thank you, friends, for watching this video until the end. Do share it with your friends and then subscribe to my channel for more such updates. You can also visit my website to get more about it. Thank you.